Alright, we're going to attempt this one more time. So I realize you're just seeing this video for the first time, but we've had computer issues once. Then the battery went dead, so this is attempt number 3 to get F2 covered. So we're going to get through it this time. Alright, so in looking at this for objective F2, what we're working on is the functions, and more specifically the comparing of functions. So essentially what that means is within the function you are going to have a slope, and the test is going to ask you to compare the slope of two different things. So they'll give you scenario A, scenario B, you find the slope of the first one, you find the slope of the second one, and you just compare them. In other words, which one's bigger, which one's smaller, that kind of thing. The easiest example I can give you, for instance, if you have a car that's driving 50 miles per hour on the left lane and you've got a car that's doing 60 miles per hour in the right lane, okay? That would be function 1, that would be function 2, and then I would ask you which one of those is traveling at a higher rate of speed. You would say the 60, because the slope of 60 is faster or larger than the slope of 50. Alright? It's that simple. We just have to get it to a point to where we have these two numbers that we can actually compare. Alright? That's where slope comes in. So within every function, you're going to have to be able to find the slope. So the good news about this is there are 3 steps that if you follow them, you will always be able to find the slope. The bad news about this is that if you don't learn these 3 steps, you're never going to be able to find the slope, and you're going to miss all the questions. So I'd much rather you get the questions right than wrong. So these 3 steps, you need to memorize them if you haven't already. Okay? As we go through it, after you memorize it, it should start to make sense to you. So even though you're memorizing the formula, even though you're sort of memorizing the steps, the theory behind why we do it this way should start to hopefully make sense to you. That's when you know you've really got it. Alright? So if we're going to talk about slope, let's go ahead and talk about the 3 different things that we need to do in order to find it. For step number 1, you're going to have to find 2 ordered pairs. Okay? They can give this to you this question to you in a graph form. They can give this to you in a table, or they can give this to you in an equation. Alright? The equation works a little bit differently, so these are the 2 that we're focused on, the graph and the table. Okay? If they give you a graph, you're going to find the line of that equation that's on the graph, and you're going to try to locate 2 ordered pairs where the line of that equation crosses at the crosshairs. Okay? We don't need to be estimating numbers on this. You need to find numbers that are exact. So you want to find where that line crosses the actual crosshair, because that gives you an actual number and not just an estimation. Okay? Alright, so from that, we're going to take those 2 ordered pairs, and then we need to label them. So the first thing I want you to do is to write out your first order pair, then write out your second order pair right next to it. Alright? Now the good part about this labeling is it's super easy, and it's just sort of an extra step in the middle to serve as kind of like the middleman between finding the order pairs and actually knowing where to place them in the actual slope formula. Okay? So where I have my big X and Y there, and my big X and my Y there, those will be the numbers of your order pairs. Okay? What I want you to do is come above it, and I want you to label this by saying the first number is the X, the second number is the Y. Over here, first number is the X, the second number is the Y. Okay? So I should have number, 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 then I've got XY, XY. The only other thing that we need to do is designate which X and which Y this is. If this is my first order pair, I'm going to have X1, Y1. This is my second order pair, so I've got X2 and Y2. Alright? So every time you've got your 2 order pairs, which each consists of an X and a Y, and then above it we're going X1, Y1, X2, Y2. Okay? As weird as that may sound, especially if you haven't worked with slope before, that's going to give us the key to the puzzle whenever we start solving, or whenever we start plugging this into our slope formula to solve for the slope. Formula for slope, if you haven't memorized it yet, we've got y2 minus y1 over x2 minus x1. Alright? If you'll notice up here, we've labeled everything that we need to plug into this formula. So I'm going to start with my y2 value. So whatever number is underneath y2, that goes in the top left of the formula. Whatever number is under y1, that goes in the top right of the formula. Whatever's in for x2, bottom left, x1, bottom right. Okay? At that point, I just need to subtract those numbers. Subtract the 2 on the top, subtract the 2 on the bottom, and then I divide them. Okay? Another way to say this, especially when you're looking at a graph, is we do have rise over run. And if you stop and think about it, it makes sense. I drew my little stick man over here. This is going to be our graph, our sample graph. If we think about the word rise, that means you're either going to go up or you're going to go down, correct? So if you look at your y-axis is the one that goes up and down. Okay, so our little stick man, in order to rise, he's either got to climb up or he's got to drop down. How far he climbs up or how far he climbs down, that tells us the number that goes on top. Alright, at the same time, he's not going to climb if he's going left or right. He's just going to run either to the left or the right because he's on flat ground, right? The slope of the x-axis is 0. So he's going to run along that slope, and if you think about it, the x2 and the x1, that's measuring the distance that we're going from left to right, just like the rise is measuring the distance that we're going up and down, alright? So all of this stuff that we're doing over here, essentially we're just finding the distance that we're moving up and down from the origin, and we're finding the distance that we're moving left and right from the origin, and then we can divide those numbers. Alright? So, aside from all that, it's kind of like that's the first part that we have to be able to do is find slope. We also have to be able to deal with equations whenever we're finding slope. So this is a formula that's called slope-intercept form. Alright? Typically you're going to have your y, you're going to have your x, those are going to stay the same along with your equal sign. The only thing that's going to change is this m changes into a number and this b changes into a number. Alright? So whatever number is touching the x, and this can also be different variables, so whatever number is touching this variable, that's always going to be your slope. You don't have to do any math behind it. You just draw a circle around it and say that number is my slope. Alright? The y-intercept is also known as your starting point or your initial value or your starting amount. That's going to be the number that's out there on the end. Okay? I'm going to give you a quick example of this one. Let's say that I have y equals 20x plus 50. Okay? I'm going to relate it back to money because everybody can understand money. Alright, so the first thing is my y and my x, they stayed the same along with the equal sign. The only thing I changed was this 20 and this plus 50 on the end. So if I were to relate this back to money, essentially what I would be saying, like if I were opening a bank account, is that when I opened the bank account, I deposited $50. So that is my starting amount. And then from that $50, if I tell you that X is the number of weeks I've had the bank account, each week I put in $20. Okay, so 50 is how much I opened it with, 20 is how much I'm putting in each week. And again, it's just like a puzzle. That's all you're doing. This is your starting amount. That's how much you're adding each week. Okay. I can also take this and I can rearrange it. Let's do, shoot, I don't know, let's do negative 10x minus, let's do plus 10x minus 50. Okay? So if I'm looking at this account, this will be more like starting a business. So let's say that I want to open up a car wash business. Okay? The first thing I need to do before I can wash any cars is I have to be able to have the supplies that I need to wash the cars, like the soap and the wax and the sponges, all that kind of stuff. So this minus 50, this is the opening of my business. I've been to Walmart, Target, wherever. I bought a bunch of cleaning supplies, probably O'Reilly if it's a car shop. So I bought a bunch of cleaning supplies. I've spent $50 on them, right? So after I've spent this $50, I'm going to start making my money back by charging $10 per car. So I'm in the hole $50, but every car I wash from here on out, I'm making $10 back, all right? So this 20 and the 10, those would be my slopes because that's how much is changing per car or per deposit. This plus 50 and this minus 50, this means I put $50 in the account. This means I spent $50 to get the company started. Alright, so that's what all those numbers mean. Alright, so with all that being said, let's go jump up here and we're going to go ahead and start working on some of these problems. I'm going to erase just a little bit. Alright, let's go back up here. So in this problem number 1, we're going to be talking about Stephen. We're going to talk about his friend Brianna. There it is. So Stephen and Brianna. Alright, Stephen's is going to be given to us in an equation. So this one is the easy one. I'm going to convert it over to slope-intercept form. Some of you may not need to. You can just go ahead and see it. But we are going to circle this 110. So that means that Stephen is going to have a slope of $110. That means that every week he works, he's putting $110 in. Alright, so I've already done this once, and again, because I had the computer issues, we started over. I pulled out 2 of my order pairs for Brianna. I've got 1, 2, 3, 4 possible order pairs. I'm using 0.70 and 2 and 2.90. So 0.70, 2 and 2.90. Alright, so in this I've got my labeling, so XY, XY, and then go back and put 1, 1, 2, 2 for first and second order pairs. So now that we've got everything labeled, we just put it in the right spot. My Y2 is 290, my Y1 is 70. my x2 is 2, and my x1 is 0, and we subtract it out. So 2 minus 0 is 2, and then in my calculator, and again, I want you using your calculator, I've got 290 minus 70, I'm going to hit enter, give me 220. So for this one, I can say 220 divided by 2 is 110. Alright, so now let's go back and look at what the actual question asks. So select the options that correctly complete the statements. We've got Stephen's rate of change is blank, Brianna's rate of change. Well, his rate of change is 110, her rate of change is 110. So that means those two things are going to be equal to each other. Alright, now it's asking about the initial amount of money. So remember, if the number next to the x is going to be our slope, the number that's out here on the end, that's going to be our initial amount. So for Stephen, it's going to be 80. I didn't write it for Brianna, so we need to go back and find that one. 110x, I'm going to have a plus. The way that you find it in a table is you need to make your x value 0. So thankfully they've already done that for us. If our x value is 0, that means on a graph we're not going anywhere left and right, we're staying on the y-axis. So if my x value is 0, that means my y-intercept is going to be 70, so all I have to do, write a 70 on the end. Okay? If you ever have a table that doesn't have a 0 for your x and they ask you for the y-axis, you have to figure out how to put a 0 in there and then work it either backwards or forwards until you find what that y value is. Alright, so if we look at Stephen, his is going to be 80, and poor Brianna, hers is going to be 70. So it's asking Stephen's initial amount of money possessed before his job as cashier is blank Brianna's. It's going to have to be greater than. He started off with $80 in his account, she started off with 70. Alright, so that's a whole lot of talking just to get one problem done. We've got it done, and we're going to move on to number 2. And again, all these problems are more or less going to be kind of repetitious. They're going to give you one scenario that you have to find the slope for, give you another scenario that you have to find the slope for, and then you compare the slopes. Okay? Alright, so let's look at number 2. We've got line P. Is shown in the graph. Which linear equation has the same y-intercept as line P? And for now, I'm actually going to skip number 2. In our class, school, whatever you want to say, we do functions before we do equations, so we are going to use slope-intercept form. We haven't made it to a point to where we've started moving those equations around yet, so I'm going to skip over number 2 for right now. Alright, let's look at number 3. Compare functions f of x and g of x described below, then drag each function to the appropriate labels on the right. More than one label may correspond to the same function. Alright, we haven't talked about f of x and g of x mainly because it's an Algebra 1 objective and not an 8th grade math objective, so we're going to clean this up a little bit. Just like in the first example, I'm going to mark through that f of x, and I'm just going to say that this is going to cover scenario A. Okay, and then I'm going to mark through the g of x, say that this is going to cover scenario B. Alright, if you ever see this written out in some kind of graph or an equation or something like this, essentially what this is telling you is that stands in for your y. So it's like we have y equals 3x minus 1. Over here we have a graph of g of x, or essentially the graph of y of this actual function. Alright, so again, it's just kind of like looking at labels. Not going to affect how we do the problem. We still need to find the slope and the y-intercept of each one, and then we just connect it to whatever our answer choices are. Alright, so we've got 3x minus 1, so we know that our slope is 3, and we know that our y-intercept, or our starting amount, is going to be negative 1. Alright, so now we need to look at the graph. In this one, we have left and right counting by 1, we have up and down counting by 1, so we don't actually have to use our formula for this. We can actually count the boxes, so we can find our rise over run. So the way that I describe this is I'm just going to choose 2 order pairs. Let's go from there to there. Alright, let's say that this is you traveling down the interstate, and this is the concert venue that you want to get to. Alright, so there's a band you want to go see, you may get super excited, so your first instinct, just hang a right, drive off the interstate, go through the ditch, drive through some different people's yards and business parking lots, jump some curbs. Shortest distance between 2 points is a straight line, and from the interstate to the concert venue, there is your straight line, right? The only problem with that is that's not good because it's illegal. So our next goal is to get from point A to point B, but we have to stay on the roads. The roads are going to be represented by all these little black grids, okay? So what I'm going to do is I'm going to go over 1 and go down 1, okay? If you want to, you can even start from here and you can go in this direction. You can go down 1 and you can go over 1. Alright, in either case, we got 1 and 1. So if we think back to our formula, we do have rise over run, so I'm going to count my rise as my up and down. So in order to make this dot be equal with this dot, I need to travel down 1. So I'm going to have a -1. Then I'm going to travel to the right 1. That's going to be my +1. Alright? So there's two different ways to do this as far as your signs. Either you can just memorize that if it's sloping down and to the right, your answer is going to be a negative, and if it's sloping up and to the right, your answer would be a positive. Or you can actually plug in the numbers like a -1 and a +1, and when you divide it out, you get negative. Alright? But no matter how you do it, for this example, our slope is going to be a -1x. Alright? There's one more part we have to find. We found our slope, but remember that's only half of the slope-intercept equation. Now we have to find our y-intercept. I'm going to erase this line. It's kind of bugging me. Alright? Where is this line actually crossing our y-intercept? We can put a dot right there, and it's crossing at a -3, so that's going to give us a -3. Alright? So that means that whatever this function is, whatever it stands for, whether it's opening a business or putting money in a bank, whatever, this equation is starting off at a -3, and then they're losing 1 for whatever it is that they're doing each time they do it. Alright? This one is starting off at a -1, but they're gaining 3 every time they do it. Okay? So now we just need to match these up. So we're looking for greatest initial value. So we're looking for our y-intercepts. A -1 and a -3. -1 is going to be bigger. So a -1 goes to our greatest initial value. Alright, now we need to find the greatest slope. I have a -1 and a +3. +3 is bigger than a -1, so that's our greatest slope. Alright, so if these are both the greatest, that means these both have to be the least or the smallest. So that's my least initial value, and that is my least slope. Alright, so that takes care of number 3. Let's look over at number 4. Alright. For number 4, we got two linear functions are shown below. We got function A and function B. Alright, we're going to go ahead and rearrange this one. This one's kind of easy. So we got a 2x. All we need to do is throw it across the equal sign. And remember, when you throw it across the equal sign, you have to do the inverse. So if it's adding a 2x over here, when we move it across, we either have to make it a -2x or we have to subtract it. But that's going to be my new slope-intercept form equation, whereas -2 is my slope, 3 is my y-intercept. Right? So now I need to look down here at my chart. I need to figure out what is my slope and my y-intercept from this one. So I'm just going to choose the first two. Got -2, -3. I've got a 0, -4. And now I need to go back and label them. So that's going to give me an x and a y, and an x and a y. Alright, so there's one more thing I have to do for my labeling. This is my first order pair, x1, y1. This is my second order pair, x2 and y2. Alright, so now that I have that, I need to plug it into my formula. I need to figure out what this is going to work out to be. So y2 is a -4, y1 is a -3, so minus a -3. Be careful because you got to keep that sign. Down here I've got x2, which is a 0, minus a -2. Alright, if you are uncomfortable with negatives, please make sure that you use your calculator. Again, you've got it, might as well use it. So we're going -4 minus a -3. We're going to hit enter, and that is going to give us a -1. Another way to look at it is that whenever you have a minus and negative, that's the same thing as saying plus a positive. So you owe somebody $4, you give them 3, you still owe them $1. Down here, 0 minus a -2, that'd be like plus a positive, or you can use your calculator. That's going to give us a +2. Alright, so my slope for this one is going to be -1/2 x. Alright, we're still missing our y-intercept, but if you remember from the previous problem, all you have to do is figure out where is your x equal to 0. So when the x is 0, my y value is equal to a -4. So that means my y-intercept has to be a -4. Alright, so now that we have all our information, we can go back and we can look at our answer choices and figure out which one of these is going to be correct. We've got option A, the rate of change for function B is the same as the rate of change for function A. So this has a rate of change of -1/2. This has a rate of change of -2. Not the same number, it's off the list. The rate of change for function B is 1/4 the rate of change for function A. So to figure that out, we're going to say -2 times 1/4, which is 0.25, and hit enter. And sure enough, it comes out to be negative 0.5. So B is going to be our answer choice. Okay. All right, let's look at number 5. Got two lines, H and J, are shown in the graph below. Line H has the same y-intercept as blank, and blank has the same rate of change as line J. So we've got some multiple ones down here. Alright, so let's look at this one real quick. So we're looking for the same y-intercept, and it's giving us different things. Alright, so we can't say that it has the same as line J, because line J has a y-intercept about 1, and H has a y-intercept at 2. So that means J's off the list. Alright, our y-intercept, remember, is always on the end. So with this one has a -3. So if we choose this answer, we're saying 1, 2, 3, and that's not going to work out. So that doesn't have the same y-intercept as J, because we need to find the one that has a 1. At least it looks like a 1. And then for the next one, we are going to have y equals negative 2x plus 2. So for this one, and again, we're trying to find H, not J. But for this one, we're going to end up having a +2, and our y-intercept for H is going to be at +2. So that one's going to be our answer. All right. So now we can move over and look for the same slope. I'll write that one down. Slope of J, and this was the y-intercept of H. All right. So let's look for the slope of J. This one has a slope of -3. And if I look at J, I'm starting there, I'm going to there, so down 1, 2, 3 over 1. So down 3 over 1, that gives me a slope of -3. So my slope for J, remember you got to use points at the crosshairs. So my slope for J is down 3 over 1, and that's going to match up with that first one. Okay? It can't be line H, because H has a positive slope, J has a negative slope, so it doesn't matter if the numbers match or not, it's off the list. And this one also has a positive slope of 3. So if J has a negative slope, I can't have anything with a positive slope. So that's the only number that's even remotely possible. Alright, let's look at number 6. Now consider the linear functions of AX and BX described below. Again, don't let that stuff mess you up. We're just going to say Y, and we'll know this is the first scenario and that's the second scenario. Okay? I don't like the way that's written the way it is, so I'm going to rearrange it. So I'm going to go with y equals a negative x plus 10. Okay, so all I did was just flip that around a little bit. The graph of bx is a straight line that includes points 0, 5, and 10, 0, which statement is true about the two functions. Alright, it's talking about rate of change, so let's go ahead and work this one out. We've got 0, 5, 10, 0, so write your two-order pair. Step 2 says to label it. xy, xy, this is the first order pair, that's the second order pair. So 0 minus 5 over 10 minus 0, negative 5 over 10, so negative 1/2. So my slope for B is going to be a negative 1/2. Okay. Alright, so in looking at our answer choices, we're starting off with A, saying A of X has a negative rate of change and B of X has a positive. Well, A has a negative and B has a negative. Answer choice A is out. Both functions have a y-intercept of 10. That one has a y-intercept of 10. This one has a y-intercept. Remember, when your x is 0, the other number is your y-intercept. This one has a y-intercept of 5. That one's off the list. A of X has a positive rate of change. Nope. It's got a negative rate of change. And then both functions have an x-intercept of 10. You don't hear a lot about x-intercepts, but this one in fact does have an x-intercept of 10, and if we were to plug in a 0, let's see, x-intercept, plug in a 0 for that, cancel out, and that would give us 10. So both intercepts are going to have an x-intercept of 10. Alright, so that takes care of those. Alright, flip over, last page. Let's look at number 7. So on number 7, we got function A is going to be represented by, dadgummit. Well, I'll tell you what, we'll work this one. This again, we're rearranging the equation. I didn't like that, but we'll go ahead and we'll mess with it. We got a negative 2x plus y equals 8. The whole point in getting it into slope intercept form is to get that y by itself, which means that this minus 2x, it's got to move. It has to go over there to the other side. If it's a negative 2x on the left side of the equation. When it moves across, we got to do the inverse of it, and it's going to become a positive 2x plus 8. Okay, so that's going to be my slope-intercept form for my equation. There's my slope, there's my y-intercept. Alright, so now we need to look back at the actual table. So we need to find our slope for that. I've got 1, 4, got 3, 3. We're going to label it xy, xy, 1, 1, 2, 2. Plug it in our slope formula. 3 minus 4 over 3 minus 1. So negative 1 over 2. So negative 1/2. X. Alright, so now we need to go back. And this is one of those situations where if you look at it, we don't have a 0. So if we want to find our y-intercept, we're going to have to add a 0. Okay? This one gets a little tricky because it looks like these are counting by 1, which they are. 1 to 2, 2 to 3, 3 to 4. But these are not counting by 1s. They're counting by 2s. So realistically, the next one that I'm going to have up here is a negative 1, and then it would be 4 plus 1 is 5. Well, I'm not looking for the negative 1, I'm looking for the 0. So I want to know what is halfway in between a 4 and a 5, and that's going to give us 4.5. So that means my y-intercept over here is going to give me a 4.5. So again, we're just working it backwards. We just had to add 2 numbers instead of 1, and we had to come up with a half value in between. Alright, so now let's look at our answer choices. Select all that apply. So that means we know we're going to have more than one. Rate of change for A is greater than the rate of change for B. So my rate of change for A is 2. Rate of change for B is negative 1/2. 2 is greater than 1/2. So that is an answer choice right there on the top. Rate of change for A is negative. I got a positive 2, not a negative 2. So that one's off. 2 functions have the same rate of change. 2 is not the same as 1/2. Off my list. 2 functions will create a set of perpendicular lines if graphed. We haven't done equations yet, which means we certainly haven't done perpendicular lines. However, once you get to algebra, that will be true. The rate of change for B is greater than the rate of change for A. Negative 1/2 is not greater than 2, so that one's out. Okay, so essentially we've got 2 correct answers, even though we don't talk about that one, not yet. All right, last question, number 8. 2 functions are shown. Okay, so in looking at this, for whatever reason, didn't even print off what they were looking for. So let's just write out the equations and talk about it. Alright, so for function A, we have a graph. Alright, let's see if we can find 2 crosshairs. It's touching the crosshair there, and it's going to touch right out here on the end. So that means I can do my rise over run trick and not have to do the actual equation. So I'm going down 1, so that's going to be my top number. I'm going over 1, 2, 3, 4. That's going to be my bottom number, and because it's sloping down and to the right, I have a negative 1/4. Stick my x next to it. So now I need to figure out what my y-intercept is. Now I'm not a real big fan of this question because that would be about 0.5 there. So we'd have about 3.5. So I'm going to say this is around 3.2, probably 3.25. They like to keep things in big numbers or at rounded off numbers, so 0.25, like a quarter. Alright, so we're going to have that as our formula. Y equals negative 1/4 x, and again, that's my 1, that's my 4, it's sloping down, so it's negative, plus, and we're just going to say 3.25. Okay, it's not quite to 3.5, so we're going to round it off to that. Alright, let's look over here at function B. Alright, on function B, we need to find our slope and our y-intercept so we can make all the different comparisons. It's going to pick 2. Let's do 0 and 2. Let's do 1 and 5. Alright, so there's my x, there's my y, x, and y. Got a 1, a 1, got a 2, and a 2. So my slope formula tells me y2 minus y1 over x2 minus x1, 3 over 1. So my slope is going to be 3. So 3x for my slope. And then whenever my x is 0, my y value is my y-intercept. So 3x plus 2. Alright. So if I ask you to compare these, if I ask you things like which one of these has a greater rate of change, you would say that this one does, because 3 is greater than negative 1/4. So that one has a greater rate of change. Alright. If I ask you which one of those has a greater y-intercept, or a greater starting amount, or a greater initial value, you would say this one, because the 3.25 is going to be greater than the 2. So 3.25 is greater than 2. That one has a larger starting amount. Okay? Alright, and basically that's going to be about it. That's the only things they can ask you from it. So, with the exception of, I think, one problem, we were able to work all these, and we're not skipping that problem because we can't work it. It's just not in our objective, so we're not going to work it. We're going to focus on the stuff that's going to be on the state test and focus on the stuff that you need to learn this year first. Alright? So again, I cannot stress to you enough, if you are trying to find the slope, first thing you need, 2 order pairs. Second thing I'm making you do, if you want me to give you full credit, label them. You got the x, y's, 1, 1 for your first order pair, 2, 2 for your second order pair, and then finally your slope formula. X2 minus x1, and that equals slope. Alright? So that was, I think, what, 8 examples, 7, 8 examples of how you work with slope and slope-intercept formula. So, if you got any questions, make sure you track me down either before school or during my acceleration time. I'll be happy to work with you. You just got to let me know that you're having some issues with it.